Hello viewers, welcome to my channel Knowledge Unlimited, and in this video we are going to discuss about different test signals that we often use in the control systems. So before going to the video, what exactly the test signal means? So if you going to apply an input to the system and suppose that TF is the transfer function of the system, then you are going to obtain the output for the system. So the inputs that are applied to the system to obtain the transfer function or the output of the system can be called as the test signals. So in this video it will take two videos because the impulse function, a derivation of the transfer function for the impulse function is very important, and if once you are thorough with that, then you can derive the other three functions, that is a unit step function and the ramp function and the parabolic function, very easily. And at the end of the video we are going to discuss why unit step function is called as the standard test signal in the control systems, and why we are going to deal a different sums, or why we are going to solve a numerous number of sums that we are taking as unit step function as the basic test input for the control system. So if you watch these two videos consecutively, then you are going to get the idea that why we are called as the unit step function as the basic or the standard test signal. And in this video we are going to discuss about the impulse function followed by unit step function, a parabolic function and the ramp function. Following sequence will be followed for all the different test signals that we are going to see in this video. That is, we are going to apply the input. Let me take it as R of t, and it is applied to the system. Let the transfer function of the system be TF. Then the output we are going to obtain is C of t. If you take the Laplace transform, you know that the transfer function equal to Laplace transform of output, that is C of t, by Laplace transform of input, that is R of t. So this can be also written as Laplace transform of C of t, that is the response that will be obtained due to the input that we are going to apply, nothing but the test signal, equal to transfer function into Laplace transform of R of t. So this is the final form that we are going to use for all the different test signals that we are going to study in this video. So what is an impulse function? So if you take this as the axis, then the impulse function is defined as del of t, which is equal to 1 at t equal to 0, and which is equal to 0 other than t equal to 0. So if you consider this, the other values it will be 0, and at t equal to 0 its value is 1. So what exactly this means? This can be also written as the area under this curve is equal to unity. You can say the area under this is unity. So how actually this is obtained means, if you take a small difference like delta by 4 and delta by 4, the area under this should be 1, then the height is limited. So if you decrease this, still the area should be 1, this may be decreased further. So in this way, if you consider for small interval of time, that is very negligible small, you can call it as 0 plus and 0 minus, the area under this is 1, so that this axis should be 10 to infinity. If you multiply this, this can be approximated as a rectangle, and if you multiply this height and width, then you will get the area under this as unity. So that is called as impulse function. Now you can observe that clearly. What is the value of t minus a when it should be equal to 1? Means you have to equate the argument of the function, that is the function that is present in the bracket. Here I am equating t equal to 0, and here t minus a equal to 0. So at t equal to a, you will get the function value as unity. So you can write, suppose this is my a along the t axis, then here my value should be 1. So this is the actual definition of the impulse function. So what exactly happens when you set the input of the function as the impulse function? So if you apply the input as the impulse function to the system, then the response that is obtained can be called as the impulse response. So the response obtained when the input to the system is impulse function can be called as impulse response. So now I can write from this equation, that is from this equation, if you rewrite it as Laplace transform of C of t is the output, that is the impulse response, Laplace transform of impulse response equal to transfer function times of Laplace transform of del of t. From the formula of Laplace transform, you can write this Laplace transform of del of t as 1, that is integral minus infinity to infinity del of t into e power minus st dt. This will exist only at t equal to 0, so this will become 1, and the integral or the area under this curve that we have drawn already is unity, so you can write this as 1. So simply we can derive a final relation, that is transfer function equal to Laplace transform of impulse response. So we are going to use this relation, that is transfer function equal to Laplace transform of impulse response, to obtain for remaining 3, that is for unit ramp and parabolic functions also. So from this basic response or from this basic relation, you can derive all the other 3. So that's all for this video, and in the next video we are going to discuss about a unit step function and a ramp signal and the parabolic function. Thank you for watching, and please subscribe to our channel for more videos.